Broadly speaking, statistics is a science of using data to draw conclusions or answer questions. Preferably, we like to provide some measure of confidence in those conclusions. And the data that we use are facts or propositions that describe characteristics of an individual. A key aspect of data is that they vary. And so one thing that statistics attempts to do is to describe and understand those sources of variability. Generally, one goal of statistics is to make some of those conclusions about populations. Population would be the entire group of individuals under consideration in a study. Often, though, populations are large, and it would be impractical to study the entire population, so a sample or a subset of that population is studied. Now, although this illustration shows people as our individuals, samples, and population, we don't always have to be studying people. For example, we could ask a question or study the cars that come out of a certain factory. And so the population would be every car that comes out of that factory. A sample would be a selection of the cars that come out, and an individual would be one particular car that comes off of that factory line. And then when we use a sample to come up with a numerical summary of some characteristic, we call that numerical summary a statistic. So the word statistic is a numerical summary based on a sample. So we want to keep that in mind, that statistic comes from a sample. Descriptive statistics focuses on organizing and summarizing data, usually using tables, charts, and graphs. And then inferential statistics take some of that information basically a step further and uses sample results to extend those to the population to make conclusions about the entire population. That would have to go along with some measure of reliability or confidence in the result. A parameter is a numerical summary of an entire population. So if it's practical, or if we have access to population data, then measuring some feature or characteristic of that, that would be a parameter. So we'll take a look at a couple of examples and identify them as either parameters or statistics. And so the key distinction is that parameters are measures of an entire population, and statistics are measures of a sample. Conveniently, parameter starts with a P, and that measures a characteristic of a population, which also starts with a P, and statistic starts with an S, and that measures the characteristic of a sample, which also starts with an S. So if we suppose that 48.2% of all students on your campus own a car, does that value represent a parameter or a statistic? Because that is a percentage of all students on your campus, that would be a population characteristic and therefore a parameter. If we suppose a sample of 100 students is obtained, and from the sample we find that 46% own a car, that value, because it's only referring to a percentage of that sample of 100 students, that value is a statistic because it's a feature of that sample.